So, in problem number 1, we're asked to find when is the particle moving to the right, when is it moving to the left, and when does it stop? All right. Well, in part A, I'm going to be looking at this function 5 cosine t, which I believe starts here up at 5 and goes down and goes up and goes back up. And here we are at pi over 2. Now, if this is velocity and this is time, when are we moving to the right? We're moving to the right wherever the velocity is positive. So the answer to part A is we're moving to the right on the interval from 0 to pi over 2 and from 3 pi over 2 to 2 pi. When are we moving to the left? When the velocity is negative, and that happens from pi over 2 to 3 pi over 2. And then when is it stopped? Velocity is equal to 0 when t is pi over 2 and 3 pi over 2. Yes, Julie?
How do you want us to write it? Because on the homework they had like less than and then t and then. Or
I mean,
does it matter? Like
this is equivalent to t is.
Yeah.
Actually,
No,
it's just a less than.
Mm-hmm.
You know, these are absolutely equivalent. This is the notation I see more prevalent on the AP exam, either in the questions and in the answer manuals that they give. So I would prefer to use it for you to use interval notation as compared to using inequality notation. But both of them, strictly speaking, are acceptable.
Okay.
All right. So there's part A done. Okay. How about part B? Part B. Find the particle's displacement for the given time interval.
0 to 2 pi.
Well, displacement is the same thing as net change. So that's going to be the integral from 0 to 2 pi of our velocity function, which is 5 cosine t dt. So this is going to be 5. The antiderivative of cosine is sine, as evaluated from 0 to 2 pi. This is 5 times sine of 2 pi minus sine of 0, which is 5 times 0 minus 0, which is 0. What? The net displacement is 0?
It makes sense.
It makes sense because the area here in red is equivalent, or at least the absolute value of that area is equivalent to the area in green, and they cancel each other out. If I was this particle, this would be like me starting at time 0. Here I am moving until it's pi over 2, stopping, turning, moving until I'm all the way back over to here at 3 pi over 2, making my last turn and ending up right where I started.
Real boring life.
Wow. Well, I'm glad I'm not this particle moving with velocity. But things like this move with those kinds of that kind of periodic motion all the time. Think of the bottom of a pendulum clock. All it does is go back and forth. Maybe. All right. What is the total distance traveled by this particle? Well, we could rewrite that as the integral from 0 to pi over 2 of the absolute value of cosine t dt. What they, yes?
Sorry, they defined the distance as 3. They added the 3 to the 0.
Because it starts at 3.
Well, sorry, I answered the first part of the question. What's the displacement?
Oh, okay.
So indeed, if the displacement is 0, what's the final position?
3.
Same as the initial position, 3. So I failed to answer the entire question. Now, what would they like you to do to handle this? Well, there's a couple different modes of attack that they would find acceptable. One of them is to see that this distance is 4 times the integral from 0 to pi over 2 cosine t dt. How did I get that? Let's have a discussion. Okay, Ian, you have a discussion point for this?
Yeah, because from 0 to pi over 2 cosine's always positive.
Okay, this statement is positive because it's this area right here. Okay, that explains why I can keep it because it's positive. Continue, or does Alex, you want to throw something in?
Because 4 times the area under that is area over 3. Like that's half of what's under x-axis. And
4 times pi over
We
2
dropped
equals
the
2 pi.
five.
you know what I'm saying?
So it's a little
What happened
less
to the side?
Yeah.
It's
Okay,
yeah, Josh knows what you're
okay. What I'm saying is that this area here is duplicated
Yeah,
right here,
and under.
and if you cut this in half,
Yes,
here and
there.
there. So I see this as that one piece is duplicated 4 times. Now that's because we know something about the nature of the cosine curve. Can you do this with every? No. But I can exploit what I know. Okay? Yes.
What happened to the 5?
I forgot it. Okay. Alright. And I was in the zone. Okay, by the way, worst case scenario is this. The integral from 0 to pi over 2 of 5 cosine t dt plus the integral from pi over 2 to 3 pi over 2 of negative cosine, 5 negative cosine t dt plus the integral of from 3 pi over 2 to 2 pi back to the normal 5. Okay, so which way do you want to do it? This is the worst case scenario is you make it into separate integrals where you're breaking it down where the direction change happens. Now in this one we don't have to do it because we know about that sine curve and we know about how periodic and symmetric it is. But either by this way or by using this expression, we have the ability to find the total distance traveled. I would prefer to do this myself. And because we've already solved this problem, we already know what the area underneath cosine t is. It's 1. We solved that one way back. Way back we found that the integral from 0 to pi over 2 of cosine t dt is equal to 1. So really I look at this one and say, oh, well that's 20 times 1. It's 20 units. That's the way my mind works. Yeah.
For the second part of that equation, the one to the left, yeah. Why is there a negative?
Because this part of the curve is underneath.
But wouldn't cosine from pi over 2 to 3 pi over 2 already have that?
It has a negative. We don't want the negative part. We don't want this area to cancel out.
Alright.
We want
That.
the absolute value of that curve. We want this area. So by taking the negative value that's coming out of that function and multiplying it by a negative again, it reflects that piece of the curve above the x-axis, and we get positive area, so we don't get a cancellation like we did for total displacement. Have we done enough damage to this problem? Yep. Great. All right. So let me close off this recording. Hopefully it won't crash again.